Aerial combat has long captured human imagination. It is a domain of speed, strategy, and technological prowess. For decades, powerful fighter jets ruled these skies. They were the undisputed kings of aerial warfare. These machines represented the peak of aeronautical engineering. Nations invested vast sums to develop faster, more agile, and deadlier aircraft. The sky was a theater for human ingenuity and conflict. This theater is now witnessing a dramatic new entrant. The rise of micro-drones is a new chapter. These tiny, unmanned aircraft are transforming warfare. They are small, numerous, and increasingly intelligent. Unlike their larger, piloted counterparts, micro-drones offer new possibilities. They can go places humans cannot. They can perform tasks too dangerous for pilots. Their presence is reshaping military doctrines worldwide. We must understand this shift. It is a fundamental change in how we see the sky. Comparing micro-drones with traditional fighter jets is vital. It helps us grasp the evolving nature of conflict. Each platform has unique strengths. Each also possesses inherent weaknesses. Fighter jets bring immense power and range. Micro-drones offer stealth, numbers, and expendability. Understanding this dynamic is crucial for strategists. It is also fascinating for anyone curious about technology's role. The future of air power depends on this understanding. The sky above us is no longer just for birds or mighty jets. It is becoming a complex, multi-layered space. Micro-drones are filling niches previously unimaginable. They are like the universe's countless smaller bodies. Each plays a role, often unseen but significant. This comparison is not just about machines. It is about new ideas. It explores how human conflict adapts and evolves. We are peering into a future shaped by these tiny aerial voyagers. Fighter jets are marvels of aerospace engineering. They are designed for extreme speed and maneuverability. Powerful jet engines propel them faster than sound. Their airframes withstand incredible forces. Advanced radar systems allow them to see far. They carry sophisticated missiles and cannons. Stealth technology makes some nearly invisible to enemy detection. These aircraft are the result of decades of intensive research. They represent a pinnacle of human ambition in flight. The primary uses of fighter jets are clear. They establish air superiority. This means controlling the sky over a battlefield. They can intercept enemy bombers or fighters. They also perform ground attack missions. This involves striking targets on land or sea. Some jets are specialized for reconnaissance. They gather vital intelligence from high above. Their versatility makes them indispensable in many conflict scenarios. They project power across vast distances quickly. Currently, fighter jets remain dominant in many roles. Think of fifth-generation fighters like the F-35 or Su-57. These aircraft possess unparalleled capabilities. They combine stealth, sensor fusion, and networking. However, their high cost is a significant factor. Training elite pilots also takes years and vast resources. The operational footprint of a fighter squadron is immense. These factors present challenges. They open doors for alternative solutions in some contexts. The sky's giants feel a new kind of pressure. Despite new challenges, fighter jets are not obsolete. They continue to evolve. Sixth-generation concepts are already on drawing boards. These future jets may incorporate artificial intelligence. They might control drone swarms themselves. They will likely fly faster and farther. Their role might shift towards command and control. They could become the central nodes in a network of air power. The story of the fighter jet is far from over. It is simply entering a new, more complex phase. Microdrones are a testament to miniaturization. Their technology is advancing at a breathtaking pace. Tiny, powerful processors serve as their brains. Sophisticated sensors allow them to see and navigate. Some use GPS, others use visual navigation. Many can be equipped with small cameras or even tiny explosive payloads. They communicate using radio frequencies. Some are designed to operate in swarms. This means many drones working together like insects. This collective behavior is a key technological feature. The applications for microdrones are diverse and growing. Their small size makes them ideal for reconnaissance. They can enter buildings or dense urban areas. This is often too risky for larger aircraft or ground troops. They are used for surveillance and intelligence gathering. Some microdrones are designed for targeted strikes. They can deliver small, precise effects. Swarms of microdrones could overwhelm enemy defenses. They can also be used for electronic warfare. Disrupting enemy communications is another role. Their versatility is remarkable. Compared to fighter jets, microdrones have clear advantages. They are incredibly cheap to produce in large numbers. This makes them expendable. Losing a microdrone is not like losing a multi-million-dollar jet and its pilot. Their small size makes them difficult to detect and track. They can be launched from almost anywhere. They do not require long runways. However, they also have limitations. Their range and flight time are often short. Their payload capacity is very small. They can be vulnerable to electronic jamming or even physical countermeasures like nets or lasers. The key difference lies in philosophy. Fighter jets are exquisite, powerful, and few. Micro-drones are simple, numerous, and often disposable. One seeks dominance through superior individual capability. The other seeks to overwhelm through sheer numbers and persistence. Think of a mighty lion versus a swarm of persistent bees. Each has its own way of asserting control. The bees, in their multitude, can drive away the lion. This analogy helps us understand the new aerial dynamic. Real-world examples show this shifting dynamic. In recent conflicts, micro-drones have proven their worth. They provide cheap and effective surveillance. They have been used for precise strikes on vehicles and positions. This has happened in places like Ukraine and Syria. Fighter jets, meanwhile, continue their roles. They enforce no-fly zones. They conduct strategic bombing missions. They provide air cover for ground operations. We see both systems operating, often in different layers of the airspace. They are not always in direct opposition. The future likely involves coexistence, not replacement. Fighter jets and micro-drones can complement each other. Imagine a fighter jet acting as a mothership. It could release a swarm of micro-drones. These drones could then perform reconnaissance or attack. The jet pilot remains safe, far from danger. Micro-drones can also protect larger aircraft. They could act as decoys or intercept incoming missiles. This collaborative approach is called human-machine teaming. It leverages the strengths of both platforms. The sky becomes a more integrated battlefield. Current trends point towards greater autonomy. Artificial intelligence will play a larger role. Drones will become smarter and more independent. Swarm technology will become more sophisticated. Counter-drone technologies are also rapidly developing. These include lasers, jammers, and nets designed to stop hostile drones. For fighter jets, the focus is on networking and data fusion. They will become flying command centers. Hypersonic technologies might also enter the equation for both missiles and aircraft. The pace of change is accelerating. Ultimately, innovation will continue to shape aerial combat. The duel between micro-drones and fighter jets is just one aspect. It is part of a larger transformation. As our understanding of materials, AI, and energy evolves, so too will our creations. The sky is a canvas for human ingenuity. Whether it's a colossal jet or a tiny drone, each reflects our quest. A quest to master the vertical dimension. The future of flight, in peace and conflict, promises to be even more wondrous, and perhaps more complex than we can yet imagine.